Hi everyone, glad you can join us today. My name is Syed Rehan. I'm a senior IoT specialist solution architect with AWS, specializing in IoT and ML services. I'm based out of London. I work with customers ranging from startup to enterprises to help them adopt AWS IoT and scale with AWS IoT. And good to be here to speak with you guys. Over to you, Olivier.
Yes, thanks, Syed. Hi, everybody. So I'm Olivier Guiter, working for IoT Europe for a while now. IoT expert and most of the time in charge of this technical discussion with our customers. So feel free to ask us any question. And over, Olivier.
Okay, thanks, Olivier. So I'm Olivier Carmona. I'm in charge of sales and marketing. I'd like to introduce you to what we do and how we are working for this Internet of Things for AWS. So let me first give a few words about our company and IoT Europe. So we are a company created in 2016. We are a company that is really focused at making massive IoT profitable. We are believing in standards. We have been leading the OmaSpecWorks in particular, and we are a member of the board of Open Mobile Alliance, OmaSpecWorks. We are partnering with the leaders in the respective industry, and in particular we're in the field of smart metering, street lighting, and also with Amazon Web Services, and we will start today to talk about it. So first I'd like to talk about what is massive Internet of Things and what are the subject of this discussion today. So massive Internet of Things really care about addressing millions of devices directly over Internet. So those are devices that are connected directly over Internet, and they are not getting through a gateway or through a set of repeaters, gateways, and other infrastructure. So we are not talking here about devices that are LoRaWAN based or about advanced metering infrastructures, but are some solutions that we can find in some markets. It's not the subject today. The subject is about directly talking to the end devices and having those massive set of devices directly addressable have some cost. It's also a very different solution. And we have been talking and working mostly over two solutions for that. One is two cellular IoT technology, actually. One is LTE-M, which is more about when you have really a moving object that you want to track, or when you really require a permanent connection with a device, or if you want to have some high bandwidth solutions, like for instance would be some voice VoLTE coming up in LTE-M. And if you are more in a situation where your device is really deep embedded inside a building, if it's the device is requiring to have an extra long battery life, or if it's if you really require low bandwidth consumption, you would be better at choosing NB-IoT. And we will be talking today about narrowband IoT. So narrowband IoT is quite specific in that it's the latency of the network can be up to 20 seconds. The communication is constrained to some 200 kilobytes per second, and the device connect only on demand. So the devices are not permanently connected. They are connecting only when needed, because they are usually on battery, and then they don't need to be always on. As is, the narrowband IoT devices cannot connect easily to AWS out of the box precisely for these questions of latency, in particular, and also by the fact that the devices being on battery, they have some restriction in terms of connection, and we'll talk about what we are offering. But before entering in the specific of of what we are offering, just an outside look on what are the products that we are offering in general, and just we will come back to the specific solution to our solution today. So IoT Europe is offering solutions that works fine for massive IoT, and we are in particular offering a device management platform that allows you to manage the life cycle of the devices without any contact, providing commissioning with touchless commissioning, touchless decommissioning. That provides also data orchestration with end-to-end encryption. And we also provide it based on a standard, as mentioned before, the standard where we are really, for which we are member of the board, lightweight M2M. And that standard, if your device is not already lightweight M2M, we can provide you Iowa, which is our embedded client. And this client allows you to run on any hardware and provide you a way also to minimize the power consumption. It's also very easy to port on most platforms, even on bare metal implementation. And it's a solution which is documented, that provides a very minimum time of cost and time of implementation. Also because it's also made with a very simple API. So one portion of Alaska has been dedicated to one specific activity to help our customers onboard Amazon Web Services, and it is Nebraska. So what is Nebraska? Nebraska is an Amazon Web Services marketplace application, which is a secure bridge and for NB-IoT devices to talk to Amazon Web Services IoT. We do that by bringing the devices using COAP over DTLS to Nebraska, then to Amazon Web Services IoT core. Nebraska is a subset of Alaska. So here you have a full set of Alaska. Nebraska is the right side of the equation. So in the case of Alaska, we do all the lightweight M2M treatment. Nebraska is just restricted to the COAP portion of it. And that portion can talk to Amazon Web Services. It's also an important difference is also that Nebraska is an AWS marketplace application. So it works straight, easily for anybody having an Amazon Web Services account, and you can easily plug on it. And we will talk about it later on. So now, how people are using Amazon how people are using Nebraska to integrate with Amazon Web Services IoT. So here is a case where a customer is having a narrowband IoT street lights, and they have been using SendML CBOR over COAP because this way of communication was the best for in terms of latency resistance, resilience. And for that purpose, they are using Nebraska to get in Amazon Web Services IoT core. Once they get into that, they are able to use the full set of solutions that Amazon Web Services is offering in terms of analytics, in terms of storage, in terms of capability of running artificial intelligence. And in this case, they have some dedicated solutions to make alerts or create alerts or have some very advanced feature set that are really linked to their particular business, which is streetlights. So, for instance, addressing cases where the streetlights is not lit or over any cases which could be related also to the sensors that can be also on that streetlights actually. In terms of benefits for this customer, it's an important solution for them to be able to scale their deployment on narrowband IoT. Using that solution, they are not able to have the problem they were facing with latency. In particular, using MQTT was not easy and not possible in their cases. And they were also able to leverage the Amazon Web Services IoT tools, which they were using also for other devices which were not on narrowband IoT. So that's for them a very important solution for their business case. So in terms of benefits, Nebraska provides you a stable and secure cloud connection for your NB-IoT devices. It's really something that's important. By using COAP, it allows you to work asynchronously with your cloud. So you will be sending you'll be sending messages only when needed, and you will be dramatically improving the device battery life. It's also very important in terms of a cost saving for your network traffic, because if you would be working with, say, MQTT, you would have MQTT TLS in particular, you would have to face cases where you would have to send keep alive messages in order to maintain the TCP connection or the MQTT connection in that precise case. And that would be incurring some additional traffic costs, and it will also cost you the time of connection during the latency of the message. For instance, say you have 20 seconds latency, you will be maintaining a connection during 20 seconds, sending keep alive messages, and that would be quite difficult in terms of additional costs for you. In terms of also a solution, it's a solution that allows you to connect to Amazon Web Services, and you have a wealth of services, and Syed will be talking about it later on. So where do our customers use this solution? So they are using it for critical devices, in particular devices that are linked to safety, security. And we, Nebraska, ensure a stable and secure access. They ensure that the connection is made and is quickly done using asynchronous protocol like COAP. It's also a very efficient solution for on-battery devices, in particular for data logger. If you want to send your data to Amazon Web Services, in the case of a data logger, it's a solution which is quite efficient in terms of power usage for your end device. And it can work on any devices as soon as any NB-IoT devices, as soon as, for instance, the case of street lighting, which street lights are mostly connected to the to the main, but they still, Nebraska is bringing a lot of value in terms of message bandwidth, message consumption. Nebraska is also built for scaling. It's really a solution that has been built to resist and be able to work for a large amount of devices. It's a solution that our customers are using for large scale deployment for smart metering or for street lighting in particular. So now going deep into why in particular, why MQTT, which is, I would say, the default usage or default transport protocol, why MQTT here is not addressing or is not addressing as well your solution. Well, MQTT consumes too much due to the nature of an outbound IoT. It's MQTT-less rely on a synchronous protocol, so you need to maintain a connection. In particular, you may need to reconnect sometimes, so that you will be inferring a certain number of reconnection during the time. Each time you do a reconnection, we will see later on that you will also need to do TLS handshake. And the latency requires also an unpredictable number of keep alive messages. So if your latency is tens of seconds, as I mentioned before, you may need to send a keep alive message every second or every 2 seconds to keep your connection up and running. So that's really the big problem that you will face. So COAP on the other side, over UDP DTLS, so is asynchronous, so no connection to maintain, no trouble with latency. And that's the reason, if you look at the data and provided by T-Mobile in their narrowband IoT solution developer protocols guide, in terms of number of transmission required for a 5-byte payload, you'd see that just due to the fact that you have that latency, whatever the sensitivity, you are inferring a certain number of packets to send and communicate. It's also true that in terms of payload, MQTT is also consuming a bit more, and you would have the numbers here put forward again by the same document from T-Mobile, where you can compare that the size of the COAP power payload compared to the MQTT payload. And you'd see that the COAP payload increases when you get further in terms of when the sensitivity is low. The sensitivity is lower on the device, so you get further, or you get a worse reception, because you have retransmissions. So for a 5-byte payload, again, you get at the worst case, you get half of what MQTT payload would offer you. And in best case, it will be more than 10 times less than with COAP compared to MQTT. And last, to finish up on that, MQTT TLS is consuming even more when comparing the DTLS versus DTLS. TLS resumption will cost you, as you can see, a significant overhead. While if you use DTLS, in particular, well, DTLS with a continuation identifier, you'd be basically using 0 overhead. So that's really a very important aspect, because we have been facing customers that were just not able to face MQTT TLS connection, because they were not even able to do the TLS handshake actually. With that, I'd like to give the show floor to Olivier, who will give us some explanation about how to use Nebraska.
First of all, from a device perspective, I think maybe the best solution is to show you how it works on the device side, and also on the AWS IoT Core UI. So you will be able to see how easy is it to use Nebraska on your environment. So I will show you more. Let me share my screen with you.
Hello everybody, let me show you in this short video how to make your IoT device communicate with Nebraska. As you will see, you will have to complete 3 stages in order to be able to play with your devices over Nebraska. So the first one is to set up your AWS account, and Nebraska accounts also. The second is how to register and provision your devices on Nebraska. And the last one is how to code your devices to communicate with Nebraska and the AWS IoT Core using COAP protocol. As Nebraska is a bridge between your devices and AWS, it means that of course you first need an AWS account. So please create it and log in to your account. And now you have to go to the AWS marketplace in order to subscribe to Nebraska. Keep in mind that Nebraska is a pay-per-use solution, so it means that you can easily control the cost usage. On button press, you will be redirected to the Nebraska subscription page. Please enter your email and choose a password. Then you will be redirected to the Nebraska login page. On the first login, Nebraska will link the account to your AWS account and create a new cloud formation stack. So please complete the role name and don't forget to check the capabilities authorization checkbox. And if everything is okay, after a few minutes, the new stack is created and you will be able to jump on stage 2, provisioning devices on Nebraska. Now it is time to authorize some devices on Nebraska. This operation is called provisioning. Provisioning is a device add an entity to the Nebraska database with some mandatory and optional values. Mandatory parameters can be credentials, MQTT, topic, etc. And as Nebraska is API powered, you can provision a batch of devices in one call, not just only one. Let's have a look at the API. Three groups are available: security, provisioning, and devices. Security allows you to retrieve the server certificate authority that will sign your certificate. You don't need to call this API if you piece key authentication. The second group is for provisioning operation, post and delete, return an operation ID. This ID is used in a subsequent API call through the API v1 MQTT provisioning operations operation ID API to retrieve the status of the requested action. Once again, the mechanism is interested in batch operation. The last group returns the list of provisioned devices. One important thing for security reason, there's no way to retrieve credentials information from Nebraska Engine. So now let's play with the API. You can use the API interface provided on Nebraska dashboard, but any usual API implementation can be used: curl, Swagger, OpenAPI add-ons, etc. You can find a GitHub Nebraska sample page, a simple shell script to provision a few devices. First, you must be authorized to play with the API. You must add your credential to get access to the API. Let's retrieve the device list. The device list is currently empty as it's a fresh start. So select try it out, execute, and the return payload give you total element value equal to 0. Now it's time to provision some devices. When called, the provisioning API call returns an operation ID. This operation will be used, as I said, in a subsequent call. So we want to provision two devices named AirSensor01 and AirSensor02 using a common PSKey authentication scheme with PSKey identity equals to IoT Web 0 and a PSKey key equal to 1, 2, 3, 4, 5, 6. And the MQTT topic is /demo/webtest, and we specify an optional parameters QoS set to 0. Please take note that the PSK secret is base 64 encoded. On execute, the response is 202, accepted, and the payload contains the operation ID. Now we can call the provisioning operation API to check the completion of the status of the previous call. As you can see, the response is 200, okay, and the payload contains the status success. The Nebraska dashboard now shows newly provisioned devices. It's time to move to the device side. Remember, we provisioned two devices that will communicate with Nebraska using a known PSK credential. So on device side, you can use any library compliant with the RFC 7252. But if you want additional features like bootstrapping and full device management, please have a look at Iowa, lightweight M2M stack. For now, I will show you a sample code available on Nebraska GitHub pages with the classic libcoap library. And this sample we can communicate with AWS IoT Core. In this sample, libcoap library is built against embed TLS. At boot time, the device will set up a secure session with a Nebraska server. Samples are available for Linux, Zephyr Amazon FreeRTOS, etc. Two levels of COAP frame exchange, registration and publication. The first COAP frame sent to the server is a registration request post comment. Nebraska will establish a link with AWS IoT Core and return a unique channel handle. Then on publication, the device will use this unique handle to publish the data to the MQTT broker. Any client that subscribes to the same topic will receive the published message. Here's sample code taken from IoT GitHub page. We just have to add the correct parameters like credential, endpoint. Let's build under Linux and run the code. We can see the registration and the publication phases. To validate the test, we switch to AWS Management Console and more precisely to the IoT Core page to use the MQTT test client. So select test, select MQTT test client, and subscribe to the topic /demo/webtest. If you want, you can change additional configuration to the display payloads as strings. It will be better. And as you can see, the running code is sending data frames, a random value to the broker each second. Well, that's all for today. Thank you. We hope you appreciate this.
Yes. So as you saw, it's just a video. It's just a way to avoid any issue while playing on the webinar, of course. So for now, I need to give back the end to Olivier. And that's all from my side. So one interesting point is, and I want to say it again, is the fact that in no way you have some specific or proprietary code on your device. The device is running, and the device side is running on any libcoap version or COAP implementation. It means that if you go to the GitHub pages, from the IoT Hub GitHub pages, you can find some sample code for NRF 9160DK, for example, or ESP32, which is so it can be a good start for you to play with Nebraska. What else? Yeah, the API solution is, from our point of view, the best way for you to manage some list of devices. It's the way we usually do that, and I think you can find that very, very useful. Just a quick schematic you show on the video. So once again, two phase. The first one is just one call to get the registration handle from the Nebraska server, and then on your device you have to publish regularly to the Nebraska server, and it go to the main AWS IoT core broker. Just a quick dump for the technical guys on the line. It's a very usual and very standard COAP frame. Thanks a lot.
So thanks Olivier. Thanks for the presentation. Thanks a lot. I'd like to give the floor to Syed.
Thank you, Olivier. So let's begin. Next slide, please. So before we dive in and look at some of the augmentation benefits of using COAP and IoT Hub solution provided by IoT Hub and augmenting with AWS IoT Core, one of the major questions a lot of customers usually ask me is that if I basically connect my devices to AWS IoT, what can I get out of it? I mean, the first question I usually ask is that, you know, IoT devices generate an immense amount of data, and that data is provided to you. And once you have the data into AWS IoT and into AWS environment, and if you know the state of those devices, what can you do? Well, pretty much everything, right? So next slide, please. So by doing that, if you look at your device's state in the field in terms of looking at anomaly created by device. So let's say if you got a windmill farm, and that's basically generating amount of electricity for you during the days, week, per month, and so on, depending on the amount of wind is basically generating. But what if you basically see the state of the wind farm and realize that there is an anomaly, and during a certain amount of time, it basically slows down. And then it gives you the information to see, okay, well, is that because of the state of the nature as the wind is, or is it because of the state of the machine itself, which is basically generating? And these anomaly patterns, basically you can understand and seek business outcome to increase the product efficiency. Next slide, please. So augmenting the solution provided by IoT Hub, which is one of the great solution because you can basically spin it off using AWS Marketplace, which means that you don't have to pay and bill separately. It will go through all through your AWS account. And one of the benefits you get once you do that is we provide you plethora of services from AWS, ranging from DevOps, if you want to basically integrate your CI/CD pipeline, mobile services, if you want to augment your mobile apps using AppSyncs or other solutions which we provide for you to develop it, or machine learning capabilities for you to understand and analyze the data sets of the machine which is basically sending it to you, or in fact, obviously create migration of your other devices over into AWS environment. So with these plethora of services, you actually have everything to go ahead and build a solution for you. Next slide, please. So what are our customers at AWS are actually doing and using AWS IoT with? So we have customers ranging from industrial IoT, where they have connected factories in the form of Volkswagen, who are basically connecting their factories to understand and streamline the development process of their vehicles. We also have customers in healthcare who are basically looking at monitoring patient health and wellness by connecting the machines, and as well as the machines which are basically kind of conducting the health scans on their body. We also have customers who are using Amazon itself, Amazon.com, because we are part of Amazon AWS. So Amazon consumes and uses the services provided by AWS. So in terms of inventory track, managing warehouse operations, and so on, it's all carried out on AWS platform. Then we also have smart buildings and smart connected cities. This is where capabilities of IoT Europe in terms of COAP, constrained devices protocol, is basically can leverage Nebraska in augmentation with AWS IoT Core. Agriculture is another great one. And then we also have renewable resources and connected car, obviously, which is the next big thing, where we have a lot of customers who are basically connecting their car, ingesting the data into AWS IoT. And finally, obviously, safety. This is where our customers basically are leveraging, connecting safety of the products. For example, if there is an issue on the floor and if somebody's basically need first aid, this is where analyzing the imagery with the machine learning data coming through is to, rather than having human intervention, automatically focus it on the person who basically needs to be dispatched to save and you provide the first aid to the person who's injured. Next slide, please. Now, our AWS IoT virtual circle is effectively goes hand in hand with everything all the way from device side to the cloud side. So the demo you've seen earlier, we have is provided by AWS IoT, AWS Amazon Free RTOS, which is our embedded MCU operating system, which is our device side software. We also have capabilities in the form of Greengrass and Device Tetris and so on. But this whole circle links it all together, so they all work hand in hand together. So if you have a data coming through from an end device which is connected to Nebraska, running free RTOS, you will send the data, it will come into IoT Core. And IoT Core is the central platform where we basically have an MQTT broker to obtain all the data coming into it. This is where we will provide you data plane and control plane. We will also provide you the Device Defender audit matrix capabilities for you to understand what's actually happening in the devices and analyze the pattern for you to understand if the device is behaving abnormally. And then obviously you can feed that into IoT analytics, IoT events, and things graph for you to create flows for you to take actions by using drag and drop actions rather than creating code as a business level logic. Next slide, please. So let's look at one of our customer sample architecture diagram where a customer basically have a connected sensor, which could be in the form of an alarm, it could be in the form of outside camera, which is monitoring, or could be in the form of a lock into their office, factory, or house. Now, these constrained devices, if they're using COAP, will basically connect to Nebraska, and then basically Nebraska will augment the bridge between AWS IoT Core and your constrained device and send the data to AWS IoT Core. Now, what happens if the data comes into IoT Core? What can you do with it? Now, once the data lands into AWS IoT Core, you can fan out the data into the form of through analytics, where you can carry out data sets and data store and section it out by creating BI. You can also push the data into our Amazon SageMaker machine learning service. So for example, if somebody basically have a camera, right? It's basically a constrained camera is sending the and analyzed images across, and as well as a door lock. So for example, if somebody comes into the door, you know it's after hours, you have identified that, you have armed the alarm because there is nobody in the building. Now that data sends it across to AWS IoT Core. You push it in as part of the data set, you push the data into machine learning, constantly analyzing based on the historic data and the pattern. So you know, for example, if it's a house, you know that, okay, based on last 10 days, 14 days, 20 days, nobody's, has been able to, nobody's been able to come to a house or factory after, let's say, 2 o'clock, 3 o'clock at night. And is this, you would understand that, okay, is this somebody who's trying to break in, or is it somebody, a normal valid user who's trying to understand and gate entry? Now, this is where modeling of SageMaker will come in and help you to identify, because you can analyze the historic data. At the same time, you can use the business logic, incorporating it into AWS IoT events and augmenting that with AWS IoT Device Defender. So for example, you realize that the person who's basically trying to come to the door is not a valid individual. You would basically arm the device to make sure every alarm is basically triggered if they try to break into the property. This is where the Device Defender and device management will send the trigger to say that, okay, well, you need to take action and make sure this person doesn't gain entry, and inform the user in the form of alerts. So using Amazon SNS, they would basically get notified by SMS, text, or in fact, even a call using Amazon Connect to say that somebody has been trying to breach into your property. And this is a great example by augmenting the solution provided by IoT ROP, because you have a constrained microcontrollers which are connected, and the COAP capabilities, which basically does the translation for you and connect to AWS IoT Core to give you the complete end-to-end edge. Next slide, please. So now, once you actually seen the architecture diagram, now you will say, okay, well, I know there are plenty of services provided by AWS. Now, if you look at, we basically divide it up into multi-layered security services. So for example, we provide you in the form of identify, if any solutions you need to basically make up in terms of the base business use case. Like for example, the one I mentioned you earlier, you would augment that with the Device Defender and device management. And similarly, you would protect it in the form of FreeRTOS and Device Defender to send it to make sure the device is armed, all of them are connected. Then you would use the Device Defender metric capabilities to audit, to make sure that analysis of the data which you have obtained from the field devices can detect and respond and mitigate automatically. So the capabilities we have from IoT side, as well as our other services such as CloudWatch, CloudTrail, and AWS Lambda, and as well as Device Defender, they can automate and investigate and respond based on the action the user has carried out as a business use case. And still, finally, for example, if you need to basically recover your devices, this is where somebody basically try to penalize your device by trying to make sure deviate from a standard action. This is where you can trigger action on the business use case to say that, hey, I know I actually have a snapshot of the device earlier. I want to basically use from the archive and basically use AWS IoT device management to bring the device back into the restorative state where it used to be working before. Next slide, please. Okay, so that would be end from me. So any questions, please feel free to ask. Or with that, I'll hand it over back to Olivier. Thank you.
Thank you, Syed. So yeah, I think that we have a set of questions already, but if you want to ask questions, don't hesitate. So Mackenzie, can you read me one of the questions?
Sure. All right, one of the first questions that we have is, can you later please elaborate on the requirements for the mobile provider side to be fulfilled? Will it work if any provider worldwide who provides NB-IoT network, can it also be used in other networks like LTE-M, GPRS, etc.?
So yes, here we have The case we have been talking about is on narrowband IoT, NB-IoT, and of course it does match that network in particular, because we are offering a solution here that is very powerful for this ecosystem, where I would say other solutions are not necessarily advanced or possible. You can still use this solution on other network, in particular if you want to lower your quantity of message or the size of the message, if you want to lower also the battery consumption of your device. This is something that will help you, whatever network, it will help you to provide something more efficient in terms of power, more efficient in terms of message size and number of message. That maybe Syed, except if you have particular comment on that.
No, I think what you have said, it pretty much sums it up, Olivier. I mean, if you basically would want to see and test it out, you can always basically use the device, IO device provided by IoT Hub on GitHub. It will be a great start for you to basically go ahead and build it and test it out.
Okay, so I think that we have not seen more questions on the feed. So I am assuming that we have been very clear, Syed and Olivier, the two. If you have, so first of all, to answer one of the first questions we had, sure, you will be able to access this video later on, and it will be put at your disposal, as well as with the presentation we made. If you have any questions coming up later on, we are here to answer your question. And if you want to onboard Nebraska and have any questions, we are here to answer your questions. And if you have questions on precise business case, business outcomes, and how to solve that, Syed will be also here to help you build your business. Syed, I'd like to give you the floor if you want to say some final words.
Sure. So as Olivier said, please do reach out to us if you have any doubt, or if you obviously have a stage fright, because some people don't like to ask questions openly. But remember, no question is a funny question, right? Feel free to ask a question. If not, reach out to us. We are happy to help you in your journey of starting with IoT as well as scaling with IoT. So we are here for you to help you with that. And thank you. And it was a pleasure to be with you guys over here. And
thanks a lot, Syed. Thanks. It was also a great pleasure to be with you. So all the team here is very happy with what we have been able to explain to you today. And I'd like to end up this webinar. And thanks everybody for attending. And thanks a lot for your questions. Thank you. Bye-bye.
Bye-bye.
thanks. Bye-bye.